Hello and welcome. So for this video, we're going to do a site-to-site VPN using IKEv2. The general idea here will be that we want to have these Alpine Linux hosts be able to connect to each other over the site-to-site VPN. The IOSV here is kind of simulating an ISP or an internet connection, and the CSR and the ASA will be the two endpoints that or peers that we build the site-to-site tunnel, and then that way the Alpine Linux hosts will be able to connect to each other. And so essentially, the ASA will have a public peer of 20.5.7.1. The CSR will have a public peer of 12.100.0.2. And then basically I've created a new lab in CML2 with these same hardware and using all the same interfaces as we see in the drawing here. I've dropped those nodes in completely fresh, so no configuration. We'll just go step by step and configure all this up, and in the end should be able to connect. So if we kind of start from the left and go to the right for the topology here, Alpine 1, its ETH0 is connected to gigabit 2 of the CSR. CSR's gigabit 1 is connected to the ISP or internet, gig 00. The ISP internet's gig 01 is connected to the ASA's gig 00, and then the ASA's gig 01 is connected to ETH0 for the Alpine 2. So we've got all the interfaces connected in the lab, and then I'll basically just be using the console for each one of these to go ahead and do the configurations. And so I have a whole notepad full of notes here for a lab that I did this exact same lab to go through, make sure everything gets configured right and actually works. So I should be able to run through this relatively quickly with the same config, and then hopefully that all works. So I'm going to start off with the Alpine 1, and then the default credentials are Cisco, and then I should have this zoomed in enough that the command line is visible in the video. The font is big enough. So one of the first things we'll need to do is we'll need to create a root account or root password, and that way we can set the static IP for this one. So I'm going to do sudo password root, and then put in the password. So now I'm going to put in, set the root password. So I'm going to do ALP1NE, ALP1NE. Okay, so now I should be able to log in as root, which I am. All right, so this one is going to be, so this is Alpine 1, and I'm going to want to set that to the 172 address. To do that, I'm going to go to root etc network directory, and I'm going to edit the interfaces file. So I'm going to change this first line here, and it's going to be static in this particular case. And we'll just add in the rest config from the notes here, 20.5 net mask. This is a /29 mask. Set the default gateway. And then change the host name to make it easy to know which one I'm on for sure. Okay, so that looks hopefully right. 172.16.20.5. Got the right mask, got the right default gateway, right host name. So we're gonna write the file in quit. And then we will need to restart. So root etc/init.d/networking restart. So basically we're made some changes to that config file and just need to restart the service here. Check the routing table, should see default gateway in there, which we have, so that's good. We'll just jump over to the Alpine 2 and do the exact same thing again. Right, sudo password root. All right, so I got the same root password set, and now I can modify the config file. So change directory to etc/network, and we'll run up vi for the interfaces file. Set that as static. Change the host name now. It's going to be Alpine 2. And so this one's going to be 10.50.3.5. The net mask .248. Gateway of 10.50.3.1. Okay, so double check on all that, looks correct. And we'll restart. There's a really good documentation page for Alpine Linux that I got this from, so I'll link that in the video. Extremely helpful. Just for basically just to be able to take this host, log in, set an IP real quick, and then move on. So now we got the two Linux hosts set up. I'm gonna jump into the ISP router because that config is relatively simple. The majority of the work is going to be on the CSR and ASA. Okay, so I'm on the ISP router here. We'll do show IP interface brief. You can see all the interfaces are down right now, so enable config T. All right, so change the host name right away. ISP internet. Go and configure the G01. We'll put description is to the ASA. Set the IP address 20.5.7.2. And that's going to be a /30 mask. No shut. Okay, so we see that interface come up. Double check my config here. 20.5.7.2 with the /30 mask. So that looks right. Let's go and do the 0.0 interface. Description to our CSR router. .100.0.1. No shutdown. We see that interface come up. Okay, so we refer to our drawing here. So the 0.1 of the ISP be 20.5.7.2. Got that. And the 0.0 the ISP 12.100.0.1. We got that. So that looks good. And that's all we really need to do here. So essentially, the way this will work then is the routing is in place here between the CSR and the ASA, since they're connected routes, locally connected. And then obviously there won't be, so this ISP really just knows how to get to either one of these. These could be seen as like branch offices. So maybe the CSR is LA and the ASA is Tokyo or something like that. And so once we configure the ASA, we'll be able to ping across. And then that's pretty much all the routing that's going to take place. And then the VPN tunnel is going to take care of the rest of it for end-to-end connectivity between the two Linux hosts. But for now, we're good with the ISP router, and we'll go to the CSR next. And now that we got this started, we'll do the same on the ASA. So it wants me to set an enable password for the ASA, which I'm going to do as pass_ASA. Okay, so this ASA will be ready to configure. And it looks like the CSR is as well. All right, so I got my notes for the CSR here. We'll change the host name. matches the topology drawing a little bit better. All right, so we'll go through and set the IPs on the interfaces that we care about here. So we'll do gig Ethernet 1. Set a description. Set the IP address. Do the same for gig 2. Description inside to LAN. IP address 172.16.20.1. /30 mask. So, and actually before I start getting into the VPN tunnel configs, I'm gonna actually do the same on the ASA. Let's set the interfaces first. Start off with the gig 00. So I'm setting the name of the interfaces outside, and it recognizes that and sets the security level to 0, which is helpful. .20.5.7.1.25.255.255.252. Shut. And then we're gonna set the the default static route to point to the IP of the ISP internet. So route outside. That'll just push any traffic to that router like we want. Need to remember to do that on the other one since I'm kind of switching up the plan here in the middle of recording. So let's go back and do the other interface 0/1. So this will be my inside interface, and then it tells me it set it to 100, which is what I want. Description inside trusted network. IP address 10.50.3.1. Okay, so both the ASA and the CSR have their interfaces configured. So as I was going through this, I noticed that my notes for the CSR were a couple things were missing that I had just done when I was going through the initial build here and just didn't put into the notes on accident. So the two things that I hadn't done previously were I found that both of the gig 1 and 2 interfaces were down, which I was expecting those to be up. At this point they weren't. So I went back and issued the no shutdown command for both of those. So they came up. So you can see show IP interface brief. So now they're up. And also in my notes didn't have the default route that I needed. So I put that in. So basically there's IP route, any network, any mask to next hop of 12.100.0.1. And so from the CSR's perspective, that's essentially it's internet gateway as we got the drawing here. So so we got the default route there, which is good. And then so I should be able to ping from the CSR to the ASA. ASA's outside interface, which is 20.5.7.1. Ping 20.5.7. And we're good there. Okay, so so we got all the interfaces up. We got all the basic configuration for the CSR, the internet router, and the ASA. Got the Alpine Linux host configured with their IP gateway and all that stuff. So let's actually see. Should be able to ping its default gateway. It's not able to. Okay, so when I look at the ASA, because I wasn't able to, from the Alpine 2, wasn't able to ping its default gateway, and sure enough, the interface is down, which I wasn't expecting. So interface 0.1. Shut. Okay, so that's up now. And let's see if that changed anything for the ping. Okay, so ping is working. So we know that I can ping from the CSR to the ASA, which is good. Alpine 2 to its default gateway, the ASA is good. And let's check this Alpine 1. See if it can ping its gateway. It can. So that is all looking pretty good now. And then basically I think all that's left is we have all the VPN specific config to do on the CSR and the ASA. So we will jump into that next. All right, so on the ASA, so we've done the initial config for the interfaces and all that. So now we're going to start with all the VPN related stuff, phase 2, phase 1, so on and so forth. So in the notes, I started off with phase 2, so that's where we'll start. So basically I'm gonna, so these will be the phase 2 transform sets. Actually, yeah. Phase 2 transform sets, one of them is going to be GCM 256 for the encryption. For GCM, there is no integrity, so we're going to explicitly set that to null. And for the other phase 2 transform set, encryption's AES-256, integrity or hash is SHA-256. So we'll basically have two phase 2 transform sets that we could potentially use in any VPN config. And the one that we do here, we're going to use GCM256. All right. Crypto, IPSec, IKEv2, IPSec proposal. We're going to call it GCM256. That's just basically an alias or a name that we're giving to this phase 2 transform set or an IPSec proposal, whatever you want to call it. Okay, so protocol, ESP, encryption, ASGCM 256. Now it says here that the for GCM that the integrity is ignored, and I don't find that to be completely true, especially for phase 1. So we're going to explicitly set it to null. I think that's just a kind of a best practice for these. Okay, so we got GCM256, set integrity to null. Let's do another one. Call this one AES256 SHA-256 is the name for it. Encryption's AES256. The hash function or integrity is SHA-256. As we kind of stated in our name there. Okay, so we do show run crypto IPSec, and then we can double check the proposals that we made here. So here we got our GCM 256, and here we got our AES 256 SHA-256. So we're good there. And now we can do start on some phase 1 proposals. And starting off, we're going to enable IKEv2 on the outside interface. Because otherwise, if we don't do that, we can set all the policies and proposals, but it's not going to negotiate. All right, so we're going to make 2 policies. We'll call one of them number 10, one of them number 20. That's like the priority in which they will attempt to negotiate. Okay, so policy number 10 here. Encryption AES GCM 256. We're going to also explicitly set the integrity to null. Set the Diffie-Hellman group to 21 and the PRF to SHA-512. And PRF is one of the things that's different between IKEv1 and IKEv2. PRF is not present in IKEv1. So we'll do our policy 20 here. Encryption AES 256. So this is going to be known as like a CBC based IKEv2. There's a really good white paper that Cisco has on all this that I'll link in the video. So this is going to be AES 256 SHA-256. We're going to do Diffie-Hellman group 19 and keep the PRF for the CBC based one the same SHA-256 as we have for the integrity, just to keep it easy. So now show run crypto IKEv2, we can look at the policies we made. So policy 10 ASG CM256 integrity null, Diffie-Hellman 21 PRF SHA, and then you get the 24 hours default for phase 1 policies. AS256 SHA-256 Diffie-Hellman 19 with the same PRF of SHA-256, so that all looks good. And later on, we're going to need to do what's known as like a no-nap statement. So we'll build some objects to help with that. Call it so out, and this is going to be related to the Alpine 2 host, Linux host that we have here connected to the ASA. All right, object network Alpine 2 host 10.50.3.5. Got a bit of a duplication in my notes there, so we'll get rid of that. And then object network. And so this is really just CSR remote is representing the remote network that's connected to the CSR router, or essentially this LAN subnet that we're going to want to connect to or send traffic to over the tunnel. So we're going to call it object network CSR remote, and really what that is this 172.16.20.0 on a /29 mask. That subnet is going to be defined in this rule here, and we'll see why we do that later in we set up the no-nap. So this is subnet 172.16.20.0. Okay. And so now we'll move into the actual tunnel configuration. And from the ASA's perspective, the peer IP that we're matching up with is 12.100.0.2, and that's the public IP, if you will, of the CSR router like we have on the diagram here. So the first thing is we're actually going to make name a crypto map that we'll call tunnels with a Z interface outside. So essentially just saying that this crypto map named tunnels is going to be associated with the outside interface. It's telling me I don't have any entries, and we'll get to that in a minute. So we got our crypto map generally for the outside interface. One of the first things we're going to need for this VPN tunnel is an interesting traffic ACL. So I'm going to call this ASA2 CSR. And I could have made objects for these networks here, but I'm just going to put in the IPs in this example. So 10.50.3.0. So our source network is going to be 10.50.3.0, 29. /29 network. The destination network is 172.16.20.0 with the same mask. I'll see that we do okay, so I got an error here. I'll just paste this one in, see if I'm just typing wrong or if my notes are wrong. Okay, so my notes are wrong. Oh yeah, it's permit IP. That's where we're wrong. Okay, so it took that. So yeah, it's just access list. We're calling it ASA to CSR, interesting traffic, ACL for the tunnel, extend permit IP, source network here and its mask, destination network here and its mask. We can do show run include. So we got access list in the config here, so we're good there. Okay, so we got our access list. Now let's go with the tunnel group. So the tunnel group is going to reference the peer. .100.0.2, which we mentioned before. With the type of IPSec LAN to LAN. I was making a bit of a mistake there. I was typing in the word type when I didn't need to. So tunnel group 12.100.0.2 IPSec attributes. There we go. Okay, so now we need to put in the pre-shared key. And for IKEv2, you put in explicitly say the local and remote authentication. In this case, it's both PSK. So IKEv2 local authentication pre-shared key. And then I'm just going to paste this in. And then I'm going to paste the next line, which is the same thing, except for now we're mentioning the remote authentication. All right, so it took that. Okay, so the main three things that to kind of summarize the progress so far, we made a crypto map and set it to be associated with outside interface. We made an interesting traffic ACL for the tunnel, which we'll be referencing in the crypto map entry here in a second. Tunnel group, pre-shared key, kind of defining that it's an IPSec tunnel. And then the crypto map entry is really what references and links everything together. So now we'll be referencing this tunnels map that we made earlier, and so we can actually start doing entries for that, and it's going to be priority number 10 for this specific tunnel. So the crypto map entry represents references the ACL that we made. We're setting the peer, which will link that to the tunnel group that we made. And then we've got to say what phase 2 transform set or IPSec proposal do we want to do, or reference for this specific tunnel, and we'll use the GCM256 that we made earlier. So basically the way that I look at this is the crypto map is really like the core that the other parts of the config reference. And it's easy to see. It's easier to see what's going on if you start there and see how everything links up, and it'll be even more prevalent when we go on the CSR because it's a little bit more involved. So we'll set our peer here. Tells me my map is incomplete, which is nice to know. Still incomplete. And now it's complete. And then one of the last steps that we'll need to configure on the ASA is we need a quote-unquote no-NAT rule. So when I send traffic from the Alpine 2 host destined for, so this Alpine 2 host at 10.50.3.5, when I send traffic to this network over the tunnel, which we're referring to as CSR remote, I don't want my source IP getting natted on the way out, because generally by default, any traffic that leaves the ASA's outside interface will get padded to the outside, the IP associated with that. And if that happens, the natting will take place first to the outside interface of the ASA. Then it won't be seen as interesting traffic for the tunnel, and it's not going to do what we want to do. So we basically just do a no-NAT statement that tells the ASA, hey, when traffic matches this source IP in this destination network, don't change the source IP. And then when that happens, it'll be seen as interesting traffic and it'll work the way that we want. So we'll go NAT, inside, outside. So it's going to traverse as a source, I'm going to go across, it'll start out on the Alpine host. It'll go across the inside interface, and then destined for routing over the outside interface for the tunnel. That's kind of the parameters we want to match here, because that's what the VPN tunnel traffic will look like in this case. So source static, and reference that Alpine 2 object that we made earlier. So it's basically just saying, here's my source IP, NAT it to the same thing, or which is effectively not changing the source IP. So source static, the Alpine 2 object, destination static, and it'll be the same thing, the CSR remote, and we do not want the destination address being added either. We want that to stay exactly the same. Okay, so that should be all the config that we need on the ASA now, for now anyways. We'll go back to the CSR. All right, so back on the CSR, we will start off with doing some phase 2 proposals here. crypto IPSec transform set GCM256 is the name that we're giving it, just like we did with the ASA. And then we'll do a second one. I'll just paste it in. Okay. So we got GCM256 like we expect, AES256, SHA-256. Okay, so that's named correctly. Cool. Okay, and so back into going over the phase 1 proposals and policy for the CSR for the IKEv2 setup. So these are already configured, and I'm just going to go over these briefly. So what we can do is show crypto IKEv2 proposal, and then like I have on the notes here, there's basically kind of a naming convention to show it's using GCM256, which PRF it's using, the Diffie-Hellman group. The second one in the list here is CBC based, so there's AES256, SHA-256 for the hash or integrity, and then the PRF and the Diffie-Hellman group. And then this last one, this other GCM, same as the top, except for the PRF is changed to SHA-512. And so basically, from the router perspective, show crypto IKEv2 proposal. These same names that you see in the notes here in the config. And then I would point out that for the GCM ones, you'll see that integrity is defined as none for those as we were talking about earlier. So those are the configured proposals, and the way to encapsulate those in a policy so they can actually be used to negotiate a tunnel to show crypto IKEv2 policy. And so you'll see, same as in the notes, we made a policy number 10. And so essentially, this policy is like the encapsulating object, if you will, for the 3 different proposals that we made. And this is essentially like the priority in which they would negotiate. Typically, you might, as a best practice, you might want to put all the higher security ones to the top. I've specifically put this GCM one at the bottom for later video when you get into debug for IKE and showing how it cycles through the different policies until it finds a match. So basically, to kind of summarize, have our proposals defined here, the encryption, the integrity when it's applicable. It is in this case for CBC, PRF, Diffie-Hellman group. So we have those proposals, and then we need to make a policy to reference those. So this is essentially the list and priority in which they will negotiate. And then moving on, I feel there's a strong need for naming conventions when we actually go in to make the tunnel config now, so we can pair up with this ASA. So basically, I just start off with what I'm going to name the access list, and then I'm going to need a profile, a keyring, and a peer. And so it'll just be the access list name _ profile _ keyring _ peer. makes things super simple. So the first thing is we can start off with a keyring, and basically for the given keyring, we're going to have a peer object, and then as attributes, the peer IP, and then the pre-shared key. So I can look that up. Show run, begin keyring. And then it shows the configured keyring like we have in the notes here. And then same thing with, so now we got the keyring. We can put in the profile. So crypto IP2 profile, we're going to say match identity remote address. So the peer IP of the ASA that we're building the tunnel to. Specifying the authentication for both remote and local. In this case, it's pre-shared key. And then inside of this profile, we're referencing the keyring that was created earlier. And so now we go to the interesting traffic ACL. We can do show IP access lists. So we've got we're calling it CSR to ASA, interesting traffic ACL for the tunnel. Source network is the 172.16.20 as we see here. And then destination 10.50.3.0 as we see on the right hand side. And so then we come to the thing that ties everything together. Okay, and so now the crypto map is kind of the core of everything, where you can see the linkages to the other aspects of config. So we can do show run. So we'll do show run, begin crypto map, and then this shows the config, same as in the notes here. So I have the crypto map entry number 10 here, set in the peer IP that we're referencing in both the keyring and the profile. And then, of course, we're calling out which specific phase 2 transform set we want to use. And then the IKEv2 profile. So the profile from the crypto map, when we go into there, we can see that it references the keyring. So the way that I look at it is like we start off with the crypto map, which is kind of the core. It references the profile. When we go to the profile, we see a reference to the keyring, and then essentially, and then to kind of finish it off, then the reference to the interesting traffic ACL. So it really pulls together the 4 pieces that you need. The crypto map is the core. It references the ACL. It references the profile, and then the profile references the keyring, and all those parts are linked together that way. And then earlier on, we configured the gig Ethernet 1 to reference the named crypto map tunnels. And so 10 here is just one entry in that. So that is it for all the configuration we need to do. And so the real test here is to see if the tunnel builds. And so I'll start off with the Alpine 1 host, and I should be able to ping the Alpine 2. So I'll go into Alpine 1. and then ping 10.50.3.5, which is the IP over here. There's no way for this Alpine 1 to be able to get to Alpine 2 without the tunnel working. And sure enough, we get a ping. And then I'll just do the same from the other side. So we got a ping there. And then we can do, so we got traffic going, tunnel's got to be up. So we do show crypto from the CSR perspective, show crypto IKEv2 ASA. And so you can see here, we got the local peer IP, the CSR, the remote peer IP, the ASA. We've negotiated, if you recall, the third proposal in the IKEv2 policy was the one with the GCM one with the SHA-512 PRS. So that's the one that negotiated here. Could do something similar. Actually, I wanted to show a very useful tool on the ASA packet tracer. So basically what we're doing here, this is a good way to show that how your natting is happening if the tunnel is actually going to build. So we're doing packet-tracer input. So it's really kind of characteristic of the Alpine 2 host. It's going to be the source here. So it's going to go across the inside interface of the ASA, TCP protocol, Alpine 2's source IP, source port 1024, destination IP, which will be, something that's in the encryption domain. Over port 443 is a destination. And then it goes through and has these different phases. So we can see our no NAT rule is working. Get to the phase 6, which is VPN allow. And then a number of phases that may or may not apply to this specific set of traffic. But the end result is that's good. And you can actually use this to, actually build the tunnel if you hadn't sent any traffic. But as we can see here, we got traffic flowing. So the tunnel is definitely up. And then in future video, I'll be doing some VPN filter to filter ports over this tunnel. Also go over running debug on both the CSR and the ASA. Break parts of the config, run debug, show what it looks like, so on and so forth. But so yeah, successful build here, literally from scratch. Yeah, so thanks for watching, and more videos to come soon. Thanks.